Alright, this is unit 4.2, and we're going to do every single practice question. This is going to be a long one, but if you want it, you can strap in. So, our first question is find the instantaneous velocity at any time t. So this is a position function, which means to find the velocity, we just take the derivative of it. So let's just use the power rule to derive it. We get t squared minus 6t plus 8. And that's our velocity function. Part B, when is the particle at rest? So to find when the particle is at rest, we just set our velocity function, which is v of t, and we set that equal to 0. So we got t squared minus 6t plus 8 equals 0. So to solve this, we just factor it into t minus 4 and then t minus 2 equals 0. So that means t equals 4 and 2, and let's label our units. T is measured in seconds, so it's going to be seconds. Alright, find the acceleration of the particle. Well, the acceleration is just the derivative of velocity, so we're just going to take the derivative of this. So we get 2t minus 6. Find the displacement of the particle. So this is a of t, equals 2t minus 6. Find the displacement of the particle for the first 3 seconds. So to find displacement, we're going to find the position of our particle when t is equal to 3 and the position of our particle when t is equal to 0. So let's start when t is equal to 3. We have s of 3 is 1/3 times t cubed minus 3, or not t, we're going to plug in 3 for t. 3 cubed minus 3 times 3 squared plus 8 times 3 minus 5. So 3 cubed is 27, 1/3 of 27 is 9, minus 3 squared is 9, 9 times 3 is 27, 8 times 4 is 24, minus 5. And then if we add all this up, s of 3 is equal to 1. So now we need to find s of 0, which we can just plug in 0 into all the t's, we'll have negative 5. So s of 0 equals negative 5. And then to find displacement, we take our s of 3 and we subtract our s of 0. So we get 1 minus negative 5, which is equal to 6. And our units are in meters, measured in meters. So 6 meters is our final answer. There we go. A ball is dropped off a 1,200 feet high cliff. The height of the ball over time is multiplied by this function, where h is the height of the ball and t is the time in seconds. First, we need to find h prime of t. So to find h prime of t, we just take the derivative of this. So let's start with finding h prime of t, which is, this is just a constant. We use the power rule for this, so we get negative 32t. And then h prime of 3, we just plug in a 3 into here. Negative 32 times 3 is negative 96. So explain what it means. We just write a little something. At 3 seconds, which is our independent variable, the ball is falling at a rate of 96 feet per second. And that's what we have to write. Now we find h double prime of t. We take the second derivative of this, so h double prime of t. So that's just the derivative of this, which is negative 32. Negative 32, which means h double prime of 3 is also negative 32. So to explain what that means, at 3 seconds, the rate at the ball is falling is increasing by 32 feet per second squared, because we're finding the rate of a rate of change. And that's our answer. The position in meters of a body at time t is s of t equals that. Find the body's acceleration each time the velocity is 0. Alright, first we need to find the velocity function and set it equal to 0 so we can find the times where the velocity is 0. So Let's start by finding the velocity function, which is just the derivative of our position function, which is 3t squared minus 12t plus 9. Alright, and then we set this equal to 0. And we can factor out, before I do anything, I'm just going to factor out a 3 out of everything, because that'll make it easier to factor later. So minus 4t is t squared plus 3 equals 0. And now I can factor that into t minus 3, and then t minus 1 equals 0. So t is equal to 1, 3. Alright, so now that we got our times when the velocity is 0, we need to find our acceleration when the velocity is 0. And in order to do that, we first need to find our acceleration function. So our acceleration is just the derivative of velocity. So let's take the derivative of this. We get 6t minus 12. And now we can just plug in our values. So a of 1 is equal to 6 times 1, which is 6, minus 12, which is negative 6. And then a of 3 is 6 times 3, which is 18. 18 minus 12 is positive 6. So our units are negative 6 meters per second squared, and positive 6 meters per second squared. And these are our two answers. Alright, question 4 says, when a particle moves on the number line, the graph s equals f of t shows the position p as a function of time. When is p moving to the left? So let's start with, what does moving to the left mean? So moving to the left means it's going down on the y-axis. But this is a position function, so where is the position going down? Well, we can see from here to here, the y value is going down, which means that p is moving to the left, and then same from here to here. So we have 2, 3, union 5 to 6. When is p moving to the right? So moving to the right means when it's going up. Remember, this is a position function, so we have from 0 to 1. When is p at rest? When it's not moving. When the y value isn't increasing or decreasing, which is from 1 to 2. Union from 3 to 5. And now we need to graph the particle's velocity. I'm going to go ahead and do that with red. So right here, the slope of this line, so velocity is just the derivative of position, so we can just graph the slopes. The slope of this line is 2, so we can go ahead and draw open circle here to 2, open circle. The slope right here is 0, so we have a slope of 0. Then from here to here, the slope is negative 4, so we have a negative 4 from 2 to 3. From here to here, the slope is 0 again, so it jumps back up to 0. And then from 5 to 6, the slope is negative 2, so right here. And this is our velocity graph. As you can see, if it makes more sense when you graph it why this function wouldn't be differentiable, because there's holes everywhere. Anyways, let's keep going on to question 5. The figure shows the velocity ds over dt equals f of t of a body moving along the coordinate line in meters per second. When does the body reverse directions? So let's start by breaking this down. This is a velocity graph. So when it reverses direction is when the velocity changes signs. So it changes signs exactly at 2 because it goes from positive to negative. So t equals 2. And it changes sign right here. And we don't know this x value, so let's go ahead and calculate this x value right here. So to do that, we need to find the slope of this line. So we can use points 9, 3, and we can also use the point 6, negative 4. 6, negative 4. To find the slope, which is y2 minus y1, so negative 4 minus 3 over x2 minus x1, so 6 minus 9, equals negative 7 over negative 3, or 7/3. Alright, now that we got the slope of this line, we're just going to find the equation for this line using point slope form. So I'm just going to use this point 9, 3. We have y minus 3 equals 7/3, which is our slope, and then x minus 9. And now we need to find, now this is the equation of this line right here. So to find this point, we can just set, we know the y is 0 at this point, so we can just set y to 0 and solve for x. We get negative 3 equals 7/3 x minus 9. Divide both sides by 7/3. We get negative 9/7 equals x minus 9. And then we add 9 to both sides, we get negative 9/7 plus 9, which we get it over 7. 9 times 7 is 63, so 63/7 equals x. And then 63 minus 9 is 54. So that's 54/7 equals x. And we can tell that's true because 7 goes up into 54 about 7 and a few more times. So this x value right here is x equals 54 over 7. So now let's go back here. It also reverses directions at t equals 54 over 7. When is the body moving at a constant speed? So constant speed means the velocity is constant, which we can see from 3 to 4, the velocity is going straight, which means it's a constant. So the velocity is moving at a constant speed from 3 to 4. Part C says, what is the body's maximum speed? So you might be tempted to look at the y value and see the maximum is right here, but speed is actually the absolute value of velocity. So we have to take the absolute value of this, so which is, so right here, the velocity is negative 4, which means the speed is 4, which means this is the maximum speed at t equals 6. So the maximum speed is 4 meters per second. 4 meters per second. Alright, what time interval is the body speeding up? So speeding up when its acceleration and velocity are both increasing. Basically when it's positive and when the slope is going up, which is from right here, 0 to 1, 0 to 1, union. And we can also have a maximum speed when the velocity and the acceleration are both negative, which means the graph has a downward slope and is negative, which is from right here, 2 to 3. 2 to 3. It's also from right here, 4 to 6. 4 to 6. And then lastly, it has a velocity and acceleration are both positive from 54/7 to 9. So 54/7 to 9. And that is our 4 answers. Question 6 says, a rock thrown vertically upwards from the surface of the moon has a velocity of 32 meters per second and reaches the height of this function. Find the rock's velocity and accelerations as functions of time. So for that, pretty easy. We just take the derivative of our function for the velocity. So the velocity is going to be, the derivative of 32t is just 32. And the derivative of negative 0.8 t squared, we just use the power rule, so we have negative 1.6. 1.6 t. Alright, so then we take the derivative again to find a of t, which is, this is a constant, so it's 0, so we get negative 1.6. How long did it take the rock to reach its highest point? So it reaches its highest point when the velocity is at 0. So if the position was like this, let's sketch this out. If it was like this, then it would reach its highest point when the position was up here, which means the slope of this line right here is 0. So we just need to set the velocity function equal to 0. So let's go ahead and do that. 32 minus 1.6 t equals 0. Subtract 32 from both sides, we get negative 1.6 t equals negative 32. Divide both sides by 1.6, we get t equals about 20 seconds as our final answer. That is not a good box. There we go. Alright. The data in the table gives the selected values for the velocity in meters per minute of a particle moving along the x-axis. The velocity is a differentiable function of time. At t equals 0 is the particle moving left or right. So it's moving, so this, you just got to remember, it's moving left if the velocity is negative, and it's moving right if the velocity is positive. So if we look at t equals 0, the velocity is negative, which means we can say left, and then to justify, we can just say because the velocity at 0 is less than 0 or negative. Is there a time during the time interval 0 is less than or equal to t, which is less than or equal to 12 minutes when the particle is at rest. Okay, so here we need to use the intermediate value theorem from unit 1. So, at t equals 0, our velocity v of 0 is equal to -3. And then our v of 12 is equal to 5. Now, is there a time when the particle is rest? We need to see if there's a value between 0 to 12 where the particle's velocity is 0, because that's when the particle is at rest. And we can see that 0 is between -3 and 5, which means yes, there is, according to the intermediate value theorem. So for that, for the justification, we can just say according to IVT, because the function is, I'm going to extend this, because the function is continuous between 0 and 12 minutes, there is a c value such that v of c equals 0 when the particle is at rest. There's a c value set when 0 is less than or equal to t, which is less than or equal to 12. So that's my justification. If there's this should be the right answer, but if the answer key says something different, just check that it's along the lines of this. Anyways, use the data from the table to approximate v prime of 10. So this is basic. This is like unit 2 stuff. We just use that, find the average rate of change between 8 and 12, and that'll approximate v prime of 10. So we can do v of 10, v of 12 minus v of 8 over 12 minus 8. And then v of 12 is equal to 5, so we have 5 minus v of 8 is equal to 7 over 12 minus 8. And then if we calculate that, that is about -1/2 as our final answer. Explain the meaning of v of 10 in the context of this problem. So when we have the velocity, when we're taking the derivative of velocity, that's the acceleration, so that means the particle's acceleration at t equals 10 is -1/2 meters per minute squared. That's it. There we go. Alright. Okay. Question 8 says the graph represents the velocity in feet per second of a particle moving along the x-axis over the time interval from t equals 0 to t equals 9. At t equals 4 is the particle moving right or left. So this is a velocity graph, which means to check if it's moving right or left, we need to check if it's positive or negative. So at t equals 4, the velocity is positive, which means it is moving to the right. So our justification can just be the particle is moving to the right because v of 4 is greater than 0. Over what time interval is the particle moving left? Well, that's when it's negative, which is from 5 to 9. So we can say in our justification, 5 to 9, or the particle is moving left from t equals 5 to t equals 9 because v of t is less than 0. At t equals 4 is the acceleration positive or negative? So for acceleration, we actually need to look at slope of the graph. So at t equals 4, the graph has a downward slope, which means the acceleration is negative. So in our justification, we can say the acceleration is negative because v prime of t is v prime of 4 is less than 0. And then what's the average velocity from 2 to 4? To find average velocity or average acceleration, we find the velocity when t is equal to 4, which is 7, and we subtract the velocity when t equals equal to 2, which is 9. That is not 7, that's 6. 6 minus 9 over 4 minus 2. And that's about 6 minus 9 is negative 3 over 2 feet per second. Second squared. Second squared. And that's our answer. At what time t is in the given interval is the particle furthest to the right? So that means when it is it's furthest to the right when the position function is at its peak. So we have to, when we're looking at the velocity function, we know the slope. We know that it's decreasing right here. We know it's increasing right here because the velocity behind 5 is positive and it's decreasing right here. So if we graph the position function, it would look like that. And then 5 would be where it's at its peak, which the horizontal tangent line. If you guys don't understand that, let me know and I'll explain it better. But I'm just going fast right now. So since it'll have a horizontal tangent line at x equals 5, x or t equals 5 will actually be the maximum to the right, because right, all the way right is the maximum y value. So at t equals 5, and then our justification can be before t equals 5, the particle is moving to the right, and after t equals 5, the particle starts moving to the left. If you don't understand that part, let me know and I'll explain it. Now we got another motion question. This is the position function and we need to find at t equals 0 is the particle moving to the right or the left. So we can first start by evaluating the velocity function and checking if it's positive or negative at t equals 0. So we start by taking the derivative of this, which is 3t equals 3t squared minus 12t plus 9, and then we set we plug in 0, so v of 0 equals 9, and then 9 is positive, so we can say the particle is moving to the right because v of 0 is greater than 0. Alright? At t equals 0 is the velocity increasing or decreasing. So now we need to take the second derivative, which is acceleration, and see if that's positive or negative. So a of t is just going to be the derivative of this, which is going to be 6t minus 12, and then a of 1, we just plug in 1, 6 minus 12 is negative 6, and negative 6 is negative, so the particle's velocity is decreasing because the acceleration is negative. Alright, last question. Let's go back. Last question, what's the displacement over the first 6 seconds? To find displacement, we just plug in 6 into here. We subtract when we plug in 0. So first let's find x of 6. X of 6 is going to be 6 cubed minus 6 times 6 squared plus 9 times To find our displacement, part C, over the first 6 seconds, we just look at our position function and we plug 6 into our position function and subtract when we plug 0 into our position function. So first we find x of 6, which is going to be equal to 6 cubed minus 6 times 6 squared plus 9 times 6 plus 11. 9 times 6 plus 11. 6 cubed is going to be 6 times 6 is 36. Let me just do this one. 36. That's about, and then plus 63 plus 11 will be 65. Yes. Yeah, because 6 times 6 squared is a 6 cubed, and then it's just that. So yeah, 65. and then x of 0, we can just see if we plug in 0 into all the t's, we'll just get 11. So x is 0 is 11, so we have 65 minus 11, which is 54 feet. Alright, that's all the practice for unit 2, so if you 4.2. So if you guys can get this down, then you're going to be great for the test. Thanks for watching, guys. I know this is a long one.